Hey guys, let's finish chapter 9. I am going to be reading some to you out of your textbook if you want to press pause and go grab it if you want to follow along with me. Also, I will be going through the statistical power applet from this day's date and looking at that power and error chart so you can watch how I'm going to do that. Before we start with what statistical power means, I'm going to be reading to you from page 540 in your textbook. I'm going to start by reading right underneath the picture. The probability of a type 1 error is the probability of rejecting the null hypothesis when it is really true. As we have already learned, this is exactly the significance level of the test. So yellow box. The significance level alpha of any fixed level test is the probability of a type 1 error. That is, alpha is the probability that the test will reject the null hypothesis when the null hypothesis is in fact true. So obviously we'll consider the consequences of a type 1 error before choosing our significance level. So what about type 2 errors? A significance test makes a type 2 error when it fails to reject the null hypothesis. That really is false. There are many values of the parameter that satisfy the alternative hypothesis. So we concentrate on one value. A high probability of a type 2 error for a particular alternative means that the test is not sensitive enough to usually detect that alternative. In the significance test setting, it is more common to report the probability that the test does reject the null when an alternative is true. That is a correct decision. This probability is called the power of the test against that specific alternative. The higher this probability, the more sensitive the test is. In other words, the test will be accurate. The test will make the decision we were kind of hoping it would make. Keep in mind, when a statistical test is run, we have evidence against the claim, against what we think the null hypothesis is. And we run the test to find, is that result statistically significant or not? Now, we're never going to eliminate making bad decisions, or I shouldn't say bad decisions, incorrect decisions. Well, the power of a test is the ability of the test to actually make the correct decision, to make the decision that our alternative could possibly be true, that the evidence that we found might actually mean something. So today we're going to investigate what statistical power is. So to do that, we are going to go through lesson 9.3, day 2. How powerful is our math? The national mean score on the math portion of the SAT is 511 with a standard deviation of 120. We believe the students at Corinth have a higher mean than the national average. To find out, we take a random sample of 8 students and find their average. We will then use the data to conduct a significance test with alpha equals 0.05. Let's write the appropriate hypothesis for the significance test. Be sure to define your parameters of interest. So mu is going to equal the true mean math SAT score at Corinth. Your null hypothesis is that our mean is really going to equal the national average, but our alternative is what we believe we have a little bit of evidence for, is that the students have a higher mean than average, so greater than 511. Well, let's suppose that the mean math SAT score at Corinth is actually 535. That is the true value of our alternative mean. Now, look, our alternative is saying we're suspicious that our scores are higher than the average. But now suppose we were able to calculate every single person's SAT math score and we got a mean of 535. So our alternative would be true because the true mean of our scores at Corinth is 535. So we're going to go to that app that I put in your guide, and we're going to look at the statistical power applet. And we're going to enter everything in, and we're going to show you what we see. All right, so we're going to enter in the null was 511. We suspect that the alternative is going to be greater than 511. We are told in the reading that the standard deviation is 120. And we have a sample size of 8. And then our alpha level was 0.05. And we know that the true mean SAT math score of everybody at Corinth is 535. And I'm going to click update. So this gives you, the top picture is the probability, the shaded region right here is the probability of getting a test result of 500, of a number greater than 511, if we assume that the null hypothesis is true. But what you see in this bottom picture, this is the power of the test, 0.14. So what is the probability that the test will find convincing evidence against the null hypothesis? Now this is your power. So your power is equal to 0.140. So what this means in context is if the mean SAT score at Corinth is really 535, there's a 14% probability that the significance test will give convincing evidence for the alternative. That's power, the probability of making the correct decision. So we want to increase the power of the test. How could we adjust each of the following factors to increase our power? We're going to use the applet to explore this scenario. All right, so the first one said, what if we increase our sample size? So let's take our sample size and let's make it, instead of 8, why don't we do 18? Update. What happened to our power? It went from 0.14 to 0.21. Let's make it 81. Update. See, the power continues to go up. So as the sample size is increasing, the power is going to increase. I'm going to set this back to 8. All right, so since the sample size, if we increase the sample size, we increase our power. Now, the reason that increasing the sample size increases the power is a larger sample will give us more information. So it will make it a little more accurate, the test. So then the power is making the correct decision based on our evidence. So if we increase our sample size, we increase the likelihood that we're going to see what we're suspicious of. All right, so let's see what happens when I change my alpha level. That's what this slider does. So if I increase alpha, let's go up to, oh, actually I'm decreasing alpha that way. That's kind of feels weird. So as I decrease alpha, what happened to the power? Ugh, it's getting lower. So as I increase alpha, what's happening to the power? The power is getting larger. Okay, so if we increase alpha level, we increase our power. Remember, alpha is the probability of a type 1 error. So if we increase the probability of a type 1 error, we actually are able to increase the power of the test. But keep in mind, if the consequences of a type 1 error are way worse, then we don't want to have, a super high alpha level. Way worse than a type 2. All right, let's see what happens with our alternative mu. Remember, we want to increase power. So what do we think we should do for our alternative? Remember, this was the real SAT score of every single student at Corinth, and it was 535. Well, what happens if we make it 555? What happens to our power? Oh, it increased. Now, what I want you to do is I want you to look at the alternative mu at 555 and look at what the national average was. It was 511. So 555 is kind of far away from 511. So it would make sense that 555 is so far away from 511 that the likelihood of it actually happening by chance alone should be kind of slim, which means that we should make our decision to reject the null correctly. Now, what happens if I change my mu to a number that's kind of closer to 511? Let's do 512. See what happens to your power. Now remember, when the mu was 535, our power was 0.14. Now if I do 512, that's only one number above 511. Our power becomes quite small. So to increase the power, we need to increase the distance between your alternative mu. Now this is what the true mean would be, and the null value. So your power is the probability of correctly rejecting the null. All right. So there's the definition of power, the probability of rejecting the null, given that the null really is false. So of course you will probably be asked to interpret the power. So here's a good template for you to use. Assuming the true parameter of interest, okay, remember we have P for proportion and mu for mean, so it depends on what your situation's describing. Assuming the true parameter of interest is blank. There is a blank percent probability of finding convincing evidence for the alternative hypothesis. And of course, we want to put that in context. So before I get into the rest of this, I do want to take a quick side trip and tell you that you are never, ever going to be asked to calculate power. You just need to understand what the power of a significance test means. And going over some of the things that we talked about, how to increase power, those kind of things you'll need to know. And the reason you're not going to be asked to calculate power is that's the formula for calculating power. So this is from a Journal of American Statistics. And the power is the probability that you're going to reject the null under the condition that the null is false. And you can see there it gets quite complicated. So you are not going to have to calculate power. However, you are going to need to know that power and the type 2 errors have a relationship. So from previous lessons, the probability of a type 1 error is alpha. Well, the probability of a type 2 error, we're going to call beta. That's that funky little symbol right here. Beta, the probability of a type 2 error, is going to equal 1 minus the power. So I have a chart that is hopefully make that a little bit, let's kind of bring everything together. So I created this chart using the table that we talked about with the type 1 and the type 2 errors. And the probability of a type 1 error is alpha. You can see that upper left box. I wrote alpha in green. And the power would be represented in the upper right box. The power is the probability of correctly rejecting the null when in fact the alternative is true. And the power is 1 minus beta. And beta was, if you look down in the lower right box, your type 2 error. So beta is the probability of a type 2 error, failing to reject the null when we should have. So the alpha and beta are inversely related. So if alpha is increasing, beta is going to decrease. And if beta decreases, the power is going to increase. If we decrease alpha, beta is going to increase, which means the power is going to decrease. So if you'll notice, your power is directly related to alpha. So if we increase alpha, we increase our power. If we decrease alpha, we decrease our power. So we saw that when we were messing around with the applet. So let's show you a problem kind of wrapping everything up. Can a 6-month exercise program increase the total body bone mineral content of young women? A team of researchers is planning a study to examine this question. The researchers would like to perform a test of null hypothesis mu is equal to 0, alternative mu is greater than 0, where mu is the true mean percent change in TBBMC during the exercise program. The power of the test to detect a mean increase in TBBMC of 1% using alpha equals 0.05 and n equals 25 subjects is 0.80. Interpret this value. So this is where I'm going to use the power interpretation template. Assuming the true mean percent change is 1%. There is an 80% probability that the test, and by test I mean the significance test, the one sample t-test because it's means. There is an 80% probability that the test gives convincing evidence for the alternative. Remember, mu is greater than 0. So assuming the true mean percent change really is 1%, there is an 80% probability that the test, the significance test, will give convincing evidence for the alternative. Find the probability of a type 1 error and the probability of a type 2 error for the test in question 1. Okay, so power 1 minus power is your type 2. Alpha is type 1. Okay, so the probability of type 2 is 1 minus 0.80, 0.20, and the probability of a type 1 error is 0.05 alpha. Determine whether each of the following changes would increase or decrease the power of the test. Explain your answers. So our original alpha was 0.05. So if we decrease alpha to 0.01, we will decrease our power. Using a smaller alpha level makes finding convincing evidence way more difficult. Let's use a larger sample size. Let's go from 25 to 100. So if we increase our sample size, we are going to increase power. As I said earlier, using a larger sample size gives us way more information, which will make it more likely for us to make the correct decision about the null hypothesis.